Okay, in front of us we have the very first exercise of the very first chapter of Herbert B. Enderton's Elements of Set Theory. And it asks the following question. Which of the following become true when the symbol for inclusion is inserted in place of the blank, and which become true when the symbol for a subset is inserted? That is a pretty straightforward question. I don't think many readers will have much of an issue with it. But let's just go through it anyways, because we're going to go through every single exercise in this book. So, okay. It's helpful to always start with definitions. That is always what I strive to do. So, or let's say S is a set, or rather, ST are sets. So then 1 S in T is true if S is an element of T. And by that I mean something like T is equal to some stuff, and then S as it is appears somewhere in there, and then you can have more stuff. Or you can have T be just equal to the set containing S, or I don't know, whatever you want to do. You can have it contain a smiley face, S, blah, blah, blah. Now, one thing that is important to notice, and it's good to make these sorts of distinctions, is that if T is equal to S, then S is not in T. Because a set can't be in itself. And that is a rule that is outlined in the first chapter. Now, why that is true is beyond the scope of this video. But anywho, let's just take this rule to be true. We're going to say that S is in T if S is contained somewhere in T, if S is an element of T. And 2, S is a subset of T if every element of S is also an element of T. So how does this work? Let's say that S in this second example is something like 1, 2, 3, and T is something like 1, 2, 3, 4, 5. Then if we go element by element, we start with 1, we ask the question, okay, 1 is an S, so is it in T too? And of course the answer is yes. So 1 is indeed in S and it's also in T. Second, 2 is 2 is an S, so the question we ask is 2 in T? And of course it is in T, so 2 also checks off. And finally, 3, we ask, since 3 is an S, does it follow that 3 is in T? And yes, it is. They are both. 3 is in both sets, so we can say that S is indeed a subset of T. But what happens if S is equal to A, B, and T is just equal to A? Then we have to check, is it true that S is a subset of T? Well, you should be able to tell that this is not the case because we have that while A is an S and A is also in T, B, unfortunately, is an S but is nowhere to be found in T. So S is not a subset of T. However, we can reverse the implication, or reverse the question, and ask, is T a subset of S? And then we can go backwards and check for every element of T, is it true that if the element is in T, it is also an S? Now we have only one element to check, so let's check. A is in T, is A also an S? Yes, that is true. So T is indeed a subset of S. All right, now we got that refresher out of the way, let's get started with the actual questions. Because even though it's a simple exercise, it can be a little bit tricky, especially considering that all these sets kind of look the same. Okay, so let's ask ourselves. All right, this is the first set, and we're going to ask each question separately, and I'm going to go ahead and do a sub part 1 and sub part 2 for each. So this is the left-hand side set. Now, is it true that this set is included in this other set? Okay, so what we have to ask is this whole thing, all of it, this entire left-hand side, found in our right-hand side? And thankfully, in this case, it is. So, since this whole thing is found within the biggest brackets of this right-hand side set, then we can say that, yes, indeed, this is true. And now let's do subpart 2, which asks the subset question of these same sets. So is it true that this left set is a subset of the right set? And for that, we have to check each element contained within the brackets and try to find its corresponding entry in the right-hand side set. So we want to figure out this time whether it is true that this element here is somewhere to be found in here. And of course, we can find it right here, as it is. Now note that even though it's here, we can see the symbol for the empty set here and here. These two elements are distinct. Because let's call this set L. Let's call this set R. Now L is a set containing only this symbol, whatever it means, while R contains this same symbol, and then after the comma, we have this other symbol. And even though these two look similar, this is the empty set, and this is a set containing the empty set. So they're not the same. But we can still do the subset check and see that this can be found right here, and thus it is also true that the left-hand side subset, the left-hand set is a subset of the right-hand set. Okay, now let's keep going. I'm gonna go ahead and skip a page. I'm gonna add one more just preemptively. Let's go back up. Oh, this should be a B. Okay, so now the question is, I see. Let's write both questions out. So this is this. First question is inclusion into the second set. I have the right number. No, one more. Okay. And then the second question is question mark right here. Of the same set. I can't draw right-hand brackets, closing brackets, but oh well, what are we going to do about it? Now, let's move this to the bottom and focus on the first question. Is it true that this whole thing is found somewhere in here? Now you'll find that surprisingly this is false because we're trying to look for this whole thing as one of the elements of this thing. And now the elements, let's call them again L and R, right? So we want to find is L in R. And the elements of R are the empty set and this set. Now, you might say, but hey, this thing is right here, right? However, you must take into account that the elements of R, you don't they don't look inside. So, what do I mean by that? I mean that the elements of R are literally exactly this symbol and literally exactly this symbol. So, we want to know whether this exact symbol, left bracket, the zero with the cross, with the slash in the middle, and the right parenthesis, as is found somewhere in here. Now this is just the zero with the little slash, and this is two left brackets followed by a zero with a slash and two right brackets. So this is not in R. Now, the more mathematical way to think about this is this this set R contains the empty set and a set containing a set containing the empty set. Whereas L is just a set containing the empty set, not a set containing a set containing the empty set. That is a mouthful. But anyway, I hope you're catching on to the general pattern of what's going on. But we'll see. Okay, now the same question. Now you should, just as a quick disclaimer, you should try these out on your own and then, just use these as guidance in case you get stuck. But we ask the same question now. So, is L a subset of R? Write it down here. Now, again, the check to do this is let's take every single element that's in L and try to find its correspondent in R. Try to find if it appears anywhere in R. So the only element of L is this. Well, the elements of R are this one and this guy. So, as you can see, this symbol is found right here. This element corresponds to this element, and thus every element in L is also an element of R, so L is indeed a subset of R. I'm going to erase this right here. Just mark this with a check mark and keep going. Okay. C1, 2. What are the sets for this? A set containing a set containing the empty set, and a set containing the empty set, and a set containing the empty set. Okay, so if I'm not mistaken, it should be something like this. I have the right number of brackets, I think I do. And is that actually the sets we're talking about? It is. Okay, cool. Fantastic. Okay, now we do the same thing. I'm going to go a bit faster now. So, is this exact symbol found anywhere inside this? And you'll see that left bracket, 0 with the slash, right bracket is nowhere to be found within the confines of the set. So, it's actually not true. And now we go for the second one, and we ask, is everything inside the outermost brackets somewhere to be found inside the outermost brackets of the right side? So is this anywhere to be found either here or here? And you'll come to find that, yes. You actually find this corresponds to this. Oops, it's not the right color. There we go. So the left-hand side is actually a subset of the right-hand side. Cool. Let's do this once more with, I see. Okay. Almost the same question. Only let's add an extra set of brackets around this dude right here. And let's just repeat the question. Whoops, missing one. The more my hand gets tired, the worse my curly braces get. So if you're going to watch this series to the bitter end, just as a disclaimer, the brackets will keep getting worse and worse. Okay. No, this is the wrong symbol. Subset. Okay. Now let's keep going. The question is this whole thing somewhere within the outermost brackets of this thing? So is it either this or is it this? And you probably spot it that indeed this whole thing is also this whole thing. Yes. The left set is contained within the right set. Ugh. I can't pronounce words anymore. Okay, it's a little better. Now the question is every element inside the outermost brackets inside the right hand side? So is this element somewhere to be found either here or here? And now you got some more practice, you should probably be saying no, this is not true. This exact pattern of symbols is nowhere within. Oh wait, yeah, no, sorry, yeah. This exact pattern of symbols is nowhere to be found either here or here. So, no, it's not true. A little nicer. Okay. And finally, let's go see our last one. So it's this thing. Okay, cool. Trying to memorize it, but I don't think I will. In all honesty. But that's okay. Math is all about mistakes. Okay. Oh my god. This, comma, a set containing this and this. And same sets, different question. My goodness. I just hope it's legible at this point. Okay, now I do want to take this one a little bit slower. So L it contains, or sorry, L is, let's call these L and R again. I'm going to use blue to differentiate them a little. Okay, L and R. Okay, there we go. So L is exactly this thing, whatever it means. While R is a set with members and this thing. Okay. So what we're asking is L one of the members of R? So is L this thing either this or is it this? I think that is a very clear answer. L is L, this thing. I'm gonna highlight it. This thing is not this. And is also not this. So L is not in R. L is not an element of R. Okay, give a little cross, a little X. And now we ask a similar question. L contains this. R contains. Also, when I say member and elements, I mean those are the exact same things. It's just whatever is inside a set. Just different words for it. I think that's right. Okay, yeah. Now the question is everything contained in L also contained in R? And what we're asking is this thing somewhere to be found inside R? Meaning, is this thing either this thing or this other thing? And you'll find that these things are not the same. So L is not a subset of R. Turns out L is neither an element nor a subset of R. That's okay. Sets come in all different shapes and sizes, and they have all kinds of quirky elements within them, and that's totally fine. We don't judge around here. We just solve exercises. Anywho, that is all for this video. See you in the next one. Now, boom.